Welcome to this video series on frequently asked questions about the Java language. In this ongoing series of videos, we'll answer commonly asked questions about the Java language. You'll come away from the video with a solution to a question that you as a developer may have. In fact, these questions have been asked by thousands of developers, so you're not alone. Our approach to every question is simple. First, we pose the question about the Java language, Java development, or best practices. Then we fill in any background material so the question makes sense. Next, we'll get into the details of the question and discuss it further. Then we'll come up with an answer. As a bonus, we'll go deeper on the answer and look at a code example showing you what to do and in some cases what not to do with a counterexample. Stick around until the very end of the video where we'll discuss the solution from an application security point of view. We'll let you know what to watch out for to ensure your code stays secure. For more videos like this, like and subscribe to be among the first to know when we release something new. Ready to get started? Let's go. So the question we address in this video is, what does the message "could not find or load main class" mean? That's a great question, and no matter what your experience level in Java is, you probably face this problem at some point, either when running your own code or an application you're trying to get running. So what does the error mean, and what are some ways we can fix it? It's a runtime error that you'll see if you attempt to execute your application code. The error means that the Java command, which is used to execute Java applications, cannot find the class you're trying to run, or in some cases, class you're trying to run is not something that can be run. When the class fails to run, the Java runtime will repeat back to you the fully qualified name of the class that it's looking for. This information is often a great clue to help you diagnose the problem. Let's look at a little background around the Java runtime startup process. When running a Java application, you use the Java command to do so. The Java command starts the Java runtime environment and loads a specified class. Then it calls that class's main method. A few things to note about the main method. It must be declared public and static. It may not return any value, that is, it must return a type of void, and it must accept a string array as a parameter. By default, the first argument to the Java command without an option is the name of the class to be called. The class name should always be fully qualified. A fully qualified class name in Java contains the package that the class originated from. So if your class is called myapp and it's in a package called com.beginsecure, the fully qualified name would be com.beginsecure.myapp. Also notice the case matters. So if the M and A in myapp are both uppercase, then that's the way they must be specified when you attempt to run the class. If the -jar option is used, the first non-option argument should be the name of the jar containing classes and resources and have the name of the startup class. The name of the class with the main method should be specified in the main-class manifest header of the accompanying manifest.mf file in the jar file that you're trying to run. With this background, let's get back to our question. What can cause the "could not find or load main class" error? After what we saw in the last few slides, the problem boils down to the Java command not being able to find the specified class. We'll look at the three primary reasons why this may happen. Reason number one is the class name is not specified. There are lots of nuanced reasons in this category. We'll cover many of them here. For example, if the package name was not provided, so instead of the com.beginsecure.myapp, you tried to run just myapp. Next, perhaps the file name or path name was used and not the package and class name. Next, the case of the package or class name was incorrect. Remember that Java is case sensitive, so if you used all lowercase myapp instead of mixed case myapp, then that could be the reason for the problem. Finally, maybe the class name was not specified or it wasn't specified in the right location on the command line. Remember, it has to be the first non-option argument after the Java command. The next broad category is related to the class path not being correct. The class path causes headaches for even the most seasoned developers. The first thing to check to see is if the class path environment variable is set, and if so, is it set correctly for your environment. If you have trouble setting it correctly, you can override the current settings on the command line when you invoke the application yourself. When Java starts up, it searches three locations for classes in this order. First, the bootstrap class path, then any installed extensions, and then the user class path, which you can specify through the class path environment variable or on the command line. Something to be aware of regarding class path is Java will pick up all files in a directory with a jar extension, but it won't pick up files with a .classic using wildcards. Finally, subdirectories in a class path are not searched. You must specify them explicitly. Next major reason is essentially everything else that can go wrong. Reasons might include use of the default package instead of the fully qualified package name. Another reason could be the class you're trying to run does not have a main method, or it doesn't follow the proper protocol: public, static, returning void, and taking a single string array parameter. Next, the delimiters between the entries in the class path might be wrong. Semicolons are used for Windows, while colons are used for Unix, Linux, and Mac OS. Finally, if you're using an IDE, there could be a variety of problems related to the setup. Debugging your IDE class path will have to be a topic for another day. So now that we know what can cause the problem and some solutions, how can we fix it if we're still stuck? First, review the tips above. This will probably solve 90% of the issues most users will have. If you still can't figure it out, try adding the -x diagnostic flag. It will give you a detailed stack trace, which can sometimes help you pinpoint the problem. We'll look at using that flag in the coding section coming up next. Another solution might be to look for whitespace characters in the command you're executing. Some fonts make it difficult in others to see a whitespace character that can be accidentally embedded in a package or class name. Also look for non-ASCII characters in your string as well. This can be especially likely if the code path you're trying to run is something that you've copied from a website. Okay, let's switch gears and take a look at some code. For this lesson, we'll be working in an Ubuntu Linux environment. The code we'll be running really doesn't matter, so we'll create a quick Hello World application. Let's edit our Java file, vi, and add the class name. Notice that we're not adding in a package statement, so this class will be in the default package. Then we'll add the main method. And finally, the system out println message that will print our Hello World message. And let's enter write quit to save our file. Let's run ls to see that our Java file has been created. And now let's compile our code by running the command javac helloworld.java. Let's run ls once again to see that we now have a class file. Now let's run that code using the Java command. To do that, we'll simply enter Java in the fully qualified class name, which, because we have no package, is simply the name of the class Hello World. When we do so, we see that it runs just fine. Now let's put this class in a jar. To do that, we run jar cf. The flag C specifies that we'll create the archive, and the flag F will specify the name of the archive that will be created. The name of the archive will be hello jar, and we'll use a star.class to get all the class files in the current directory, which in this case is the Hello World class file that we just created. Now let's echo back the contents of the jar using tvf. T means to list the table of contents. V means verbose, so we get additional output. And we already saw that F means the archive name. Our output shows that our class file, along with the manifest, is present in the jar file. Let's run ls once again so we can see what files are still in the directory. And let's get rid of the class file so we don't run that by accident in our next test. Now let's use the jar file to run our Hello World application. Enter the Java command along with -cp to specify the class path. Instead of relying on the class path environment variable, we're specifying our own class path for the execution of this command. We specify the jar that we just created that contains the Hello World class file. And then we specify the fully qualified name of the class that we want to run, which is, of course, Hello World. When we do, we get the message Hello World as expected. Okay, now let's break some things so we can see what might go wrong. First, let's run the same command again, but use all lowercase for Hello World instead of mixed case. When we run the code, we get our could not find or load Hello World class error message. Now let's run that -x diag flag that we looked at earlier. And run the command again. When we do, we get the same error message along with some very detailed stack trace information. It shows you what the class loader is doing as it attempts to find and load your class, which can sometimes be helpful in debugging a problem. Now, let's create a directory called work. We'll cd into the work directory and create a file called goodbye.java. Put this code in a package called work, and otherwise it'll be just like our Hello World class that we created earlier, except we'll write out the message goodbye. Let's compile this code with Java-C and then try to run it with the Java command. We won't specify a package name when we do so. As we might expect, we get an error message. Let's run the command again, and this time we'll specify the class path to be the full directory path up to the point where the package is located. In this case, home/bhigdon/public with a capital P. And then we specify the fully qualified class name, including the package name, work.goodbye. And when we do, we get the message goodbye as expected. Just to show this works regardless of our location, let's switch over to the /temp directory and run the same command from there. When we do, we see the code still runs even though we're no longer in the same directory, because we specify the class path when we run the Java command. Of course, if this had been set via the class path environment variable, we wouldn't need to specify it on the command line. Now let's break things again. Let's change the case of the P in public to lowercase and rerun the code. When we do, we'll see that just like with the package or class name, if the class path is not set correctly, we'll still get the same could not load main error message. And finally, if we get rid of the word public altogether, and thus specify the incorrect location of the class path, and then run the code again, we'll once again get an error message that we couldn't load the main class. When it comes to security, are there any concerns around the error could not find or load main class? First, you should always know where the code you're executing comes from. Class paths, whether specified on the command line or via an environment variable, should always be something you understand and control, so you don't inadvertently run unexpected classes or allow them to run in your environment where they can override other classes. Experiencing the error could not find or load a class in a development environment is somewhat expected, since the environment may be changing frequently due to the development of new code. But once your application is put into production, a chaotic or uncontrolled path is not acceptable. Your deployment process should be consistent and repeatable with the same outcome each time. Executing commands or loading libraries from unexpected or unintended locations could cause the execution of dangerous or malicious code. Running such code could give the user elevated privileges on your system that they wouldn't otherwise have. Take a look at CWE 114 Process Control for more details. Thanks for watching. We hope you enjoyed this video. Please like, subscribe, and share this video with others. To get our free ebook on how to write more secure Java code, go to www.beginsecuretraining.com. When writing code, always remember to begin secure.